Hello, my name is Zhibin Wang, and I come from the Department of Chemical and Biomedical Engineering, the Florida State University. And today, the topic I want to present is about superconductivity. So, what's the superconductivity? Superconductivity is an electric resistance of exactly zero, which will occur in the certain materials below a characteristic temperatures. Such like the pictures in the slide, we can see the superconductor, the resistance of the superconductor will be zero when the temperature is lower the characteristic temperature. So superconductor can carry large amounts of current with little or no loss of energy. And there are two important outstanding features of the superconductors. The first one is zero electrical resistivity. This means electrical current in superconducting rings continue indefinitely until a force is applied to oppose the current. And the second is the magnetic field inside a bulk sample is zero. It causes the Meissner effect. When a magnetic field is applied, current flows in the outer skin of the materials will leading to an induced magnetic field that exactly opposed to the applied field. So the materials is strongly magnetic as a result. And in the Meissner effect experiment, a magnetic flows above the surface of the superconductor. So what's the Meissner effect? When materials make the transitions from the normal to the superconducting states, it includes the magnetic fields from its intervals. This is called the Meissner effect. So this contrary to zero magnetic field inside a superconductor is distinct from the perfect diamagnetism, which would arise from its zero electrical resistance. So zero resistance will imply that if we try to magnetize a superconductor, current loops will be generated to exactly cancel the imposed field. This calls Lenz's law. There are two pictures show us what's the Meissner effect. So when you place a superconductor in the magnetic field, the field will be expelled below the characteristic temperature of the superconductor. And the left picture is when the temperature lower than the characteristic temperature. So we will see the superconductor in a magnetic, the field expelled below. The next feature of the superconductor is the magnetic levitations. Magnetic fields are actively excluded from the superconductors. That's the Meissner effect we talked before. If a small magnet is brought near a superconductor, it will be repelled because induced supercurrents will produce mirror image of each pulse. So if a small permanent magnet is placed above a superconductor, it can be levitated by this repulsive force, such as the picture shows below. And the next, I will talk about the history of the superconductor. The first superconductor was found in the 1910s. It's a hydrogen, and its characteristic temperature is lower 20 K. But from the 1986, people have found many kinds of superconductor, and we can see from the picture that the characteristic of the temperature of this kind of superconductor has been raised apparently. Now, more and more superconductors have been widely used for our daily life, such like the magnetic levitation train and the MRI and the superconducting. So all above is my presentation today. I will thanks Dr. Croto give me a chance to present here. Thanks very much.